Hello and welcome to assignment 5. The objective of assignment 5 is to configure the ADC to be in differential mode. To do this, we will have the force click as the input to the positive side and we use the duck ref as the input to the negative side. Let's take a look and see how we do this in code. So as normal, we start by looking at the ADC init. Here we can see that we are doing a few things. First of all, we are setting up the duck so we can use it as the negative input. We are setting the voltage reference. We are setting the output value to be so the DAC is about 1.65 volts, which is right in between our min and maximum, as the input from the force click can be anywhere from 0 to 3.3 volts. In addition, we set both MOX push and MOX neg. So push is connected to AIN5, which we by now know is the force click, and then MOX neg is connected directly to the DAC. In addition, you can see that the ADC is put in differential mode by this byte down here. Our main code is as normal. The normal init functions. We start the ADC in the software, so we're not using any of the RTC or event system this time. Yeah, and then we have the formula to convert the sample values into volts. So let's flash the device to see how it looks in the data visualizer. So as always, we start by loading the workspace. This time it's assignment 5. We set up the USART communication. And we set up the communication between the USART and the decoder. And as you can see, we now get some data. And if I press the button to get autoscale to work, we can now see that the signal varies from down at the bottom, almost 1.65, which is as expected. And the top is almost reaching 1.6, which is also as expected, as 3.3 minus 1.65 is 1.65, and 0 minus 1.65 is minus 1.65. But if you now go back and change the duck value to something else, so let's go back and change the output from the duck to not be 1.65, but something different. So we write OX, which will give us 1.024, and see how that affects the signal. So let's reflash the device. And we can see that we now have shifted the signal upwards. So the low limit is now about 1.3 volts. And if we press the button, we can see that we are capped at 2.5 volts, which is a bit strange considering 3.3 minus 1.004 is 2.276. But this is because this value is greater than our reference value set at 2.048 volts. And this is why we are experiencing this clipping. It's important to note that the reference voltage needs to be larger than the positive input minus the negative input at all times. If not, you will experience clipping. That's it for assignment 5. Thanks for tuning in.